Chemists divide the substances around us into compounds and elements. Let's look at the elements. Here is the chemical element potassium. It cuts easily, and its shiny surface dulls as it reacts with air. Potassium also reacts with water. By contrast, the element phosphorus is stored under water, but it too reacts rapidly with air. Phosphorus and potassium are similar in reacting with air, but they differ in appearance and in their behavior toward water.
Here are most of the some 100 known elements. They have similarities and differences in appearance. What can we do to order and organize the elements as in the periodic table, and perhaps even to learn and understand some of their properties?
Well, we can make observations and look for similarities and regularities. You can see similarities among these elements. Most are solid. Some are gaseous. Many of the solids are shiny. A few are not. Shininess indicates that the element is a metal. Many metals, such as silver, are ductile. That is, they can be bent without breaking and, like potassium, be cut smoothly. For contrast, sulfur lacks the shine we associate with metals, nor is sulfur ductile. Such elements are called nonmetals. Let's sort the metals from the nonmetals, first using shininess as a criterion. Here are metallic copper, chromium, zinc, samarium.
In addition to being shiny, metals are good conductors of heat and electricity. When we touch these probes together, the meter shows high electrical conductivity. When touched to silver, we see that silver is also a good conductor. Let's check potassium. It is ductile and shiny. It is also a good conductor. Silver and potassium are metals. Phosphorus looks non-metallic. It caught fire in air, and so must be tested under water. Water does not conduct. Neither does the phosphorus. Sulfur looks non-metallic and does not conduct. Sulfur and phosphorus are non-metals. Lithium is somewhat ductile and looks metallic. Like potassium, its clean surface reacts with air. The lithium turns black, except where covered with oil. The shininess and ductility of lithium indicate that it is a metal, so we expect it to conduct. It does. We proceed with the task of sorting elements into metals and nonmetals. Some conduct, and some do not. Here is carbon in the form called graphite. It has little shine, and under stress it breaks rather than bends. Graphitic carbon is hardly metallic in these properties. But look, it is an excellent conductor. It conducts like a metal, but is not very shiny or ductile.
When we use the criteria of shininess, ductility, and electroconductivity, we find that there are about 4 times as many metals as nonmetals. Evidence is inconclusive about carbon and silicon. We identified 16 elements as non-metallic. We sort out the elements, which are gases, at room temperature. The atomic numbers shown in red indicate the number of electrons held by the individual neutral atoms. Here are the gases. Let's sort out the non-metallic solids. Bromine is liquid at room temperature. We have subdivided the nonmetals into gases, liquids, and solids. Can these gases be further classified on the basis of their chemical reactions?
Potassium, we observed earlier, reacted with air. Since air contains several gaseous elements, let's see which of the gaseous elements will react with potassium. This system of glass bulbs and stopcocks allows control of the flow of the gases we wish to test. Each of the top bulbs has been filled with one of the gaseous elements: argon, chlorine, fluorine, helium, hydrogen, krypton, neon, nitrogen, oxygen, and xenon. When this stopcock is opened, the gas can leave the bulb. A small piece of potassium metal has been placed in each evacuated reaction tube. Each piece of potassium is coated with oxide, the result of reaction with air. Let's try argon first. Opening the stopcock allows the argon to enter the reaction tube containing the potassium. There is no apparent reaction. Let's try heating. The potassium melts. The oxide coat cracks, exposing shiny potassium, which slowly vaporizes, carrying the oxide dust with it. The quiet, shiny surface indicates that no reaction occurs between the gaseous argon and potassium. Next, chlorine and potassium. There is no apparent reaction, perhaps again due to the coat of oxide. When heating exposes fresh metal, reaction does begin. Solid potassium chloride forms. Next, fluorine enters a reaction tube. Again, after slight heating, reaction occurs. When surrounded by gaseous helium, the potassium melts quietly. Oxide dust escapes, but there is no evidence of reaction. Apparently, helium is inert toward potassium. With hydrogen gas, gradually reaction occurs, and considerable product collects on the sides of the tube. Analysis would show potassium hydride. Krypton is next. There is no evidence of reaction with molten potassium.